Hey guys, welcome to this video, and for today we're going to talk about faults and its importance in engineering construction. And of course, as a civil engineering student myself who majors in structural engineering, we are going to elaborate more the importance of faults or of knowing faults in engineering construction. And without further ado, let's get right straight into it. So faults are fractures in the Earth's crust along which slipping has occurred parallel to the surface of the fracture. Some are clean, sharp breaks, many, however, consist of sub-parallel faults among which total displacements have been distributed. So the term shear zone of fault zone are often used to closely spaced sub-parallel structures along which there has been distributive movement. So some faults are knife-like breaks, other faults due to frictional effects of rocks, masses sliding over on another break, or crack the rock on either side of the rupture. Some faults pulverize the rock in the fault zone to clay-like powder called gouge. By convention, the surface of rupture along which relative movement have occurred are termed fault planes. The fault surfaces in most cases are warped or curved and irregular, and hence the term fault surface is preferable to fault plane. So there are different classifications and types of fault, and these are the following. First one is a normal fault. Normal fault is a deep slip in which the hanging wall slips downward relative to the footwall. This fault occurs along a stiff fault plane with a height of 10 degrees to 20 degrees. The vertical component of the movement is large. The fault occurs due to stretching of rocks. So the second one is reverse fault. So reverse fault is a result of a severe compressive stresses where the hanging wall moves up the fault plane relative to the footwall. So the two sides of the fault move closer together. This fault is also called as thrust fault. The fault plane is low angle, resulting in a large horizontal movement. So the next one is the strike slip fault. In this type of fault, the separated blocks on either side of the fault plane move shearing off in the direction of the strike. So this fault is called the lateral fault, transcurrent fault, wrench fault, or tear fault. Another type of fault is the step fault. This fault system consisting of a number of faults with parallel fault planes, the separated blocks slipping in the same direction along parallel planes, giving a step-like feature. This fault is also called the fault terrace. So another type of fault is the true fault. So this type of fault system in which two normal faults occur whose fault planes are inclined, providing a common down throw side between them. The down thrown block between the two fault planes forms a long trench called a graben or a rift valley. Some grabens are very long and some deep and may be filled with water to become a water stream. And lastly, the last type of fault is the ridge fault. In this case, the two normal faults occur whose fault planes are providing a common upthrow between them. So the upthrown middle wedge shaped blocks forms a long ridge between the fault planes and is called the horse or fault ridge. Another one is there is additional difficulty and additional expenditure in excavation since fractured rocks are difficult to handle. Another one is earthquakes and landslides are likely to be triggered by faults. Another one is to provide earthquake-proof structures, it is necessary to have a knowledge of the location and earthquake potential of faults. So this is of particular importance in locating sites for dams and reservoirs hydropower structures, underground power, nuclear power stations, tunnels, public buildings, school and college building, etc. Another one is filling big reservoirs behind dams across river valleys may trigger movement along fault plains leading to earthquakes. Another one is faults may create passage for water percolation. They may also provide passages for mineralizing. Many fault zones are sites of mineralization. For the eighth one is fault throw and fault heave constitute most salient factors in all exploration and recovery of mineral veins and coal seams. Another one is faults may create lakes, swamps, and marshy zones. And lastly, some fault zones form potential oil traps. But what does fault really means in engineering construction? So the main significance of faults in engineering lies as a plane of weakness affecting physical properties of rocks. So fault may act as possible source of movement and may pose problem of settlement sliding, seepage, and seismicity of the civil engineering structures, depending on its nature, disposition, and location. So that is all for today. Thank you for listening. I am John Kenneth P. Esmas, a civil engineering student of University of Mindanao. Thank you.